Chapter 6, Goal 6. Prove a quadrilateral is a parallelogram based on a set of conditions. First thing I want you guys to do is fill this in. Tell me what are the 5 things that we know about a parallelogram. 2 things about sides, 2 about angles, and 1 about the diagonals. Press pause, fill in everything that you know, then you can come back and check your answer. So for sides, we know the opposite sides are congruent and the opposite sides are parallel. For angles, the opposite angles are congruent and consecutive angles are supplementary. And the diagonals bisect each other. We can use these 5 things to help prove that a quadrilateral is a parallelogram. The nice thing is, just like with triangles, we didn't need all to be proven that triangles were congruent. We don't need all 5 of these to prove that a quadrilateral is a parallelogram. The first theorem states that if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. So if they give you that these opposite sides are congruent and the same sides are parallel, that's enough to say that this quadrilateral is a parallelogram. Similarly, if they gave you that these opposite sides were both parallel and congruent, that's enough, as long as it's the same sides that are both parallel and congruent. Theorem 2 says that if both pairs of opposite sides are congruent. So trying to keep all of these congruencies and parallels and supplementaries straight is the trick here. In this case, both pairs are congruent. So these sides are congruent and these sides are congruent. That alone is enough to prove that these triangles, or that these quadrilaterals, are parallelograms. Theorem 3, if both pairs of opposite angles, now we're talking about angles, and opposite angles are congruent, then that quadrilateral is a parallelogram. So if I know these angles are congruent and these angles are congruent, I know this is a parallelogram. On the next page, we're going to check, can we justify these being parallelograms? I want you to press pause, see if you can answer these 3. Is number 1 a parallelogram? Why or why not? Same thing with number 2 and same thing with number 3. Okay, so in number 1, it's not necessarily a parallelogram. They didn't give us one pair of opposite sides being congruent and parallel, or both pairs being congruent. Remember, these arrows mean parallel, not congruent. Number 2, we could, because both pairs of opposite angles here are congruent. That's enough to say that's definitely a parallelogram. Same with number 3, we can say definitely it's a parallelogram because one pair of opposite sides are both congruent, they're both 12, and parallel, they both have the arrows. That's how we would go about justifying these. There are 2 other ways that we can prove this, though. First is Theorem 4. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So if I knew that angle D was 80 degrees and that angle A was 100 and angle C was 100, I could say that angle D is supplementary to both angle A and angle C, so this must be a parallelogram. The fifth theorem has to do with the diagonals, and it goes back to what we need to remember about diagonals. If I know I'm given the fact that the diagonals bisect each other, in other words, cut each other in half, then that is a parallelogram. The next part of our notes, use these theorems to justify for numbers 4, 5, and 6. You can use any theorems to justify this. Press pause, spend a couple of seconds thinking those through, say yes or no, and be ready to justify why. Okay, so both 4 and 5 are yes. In number 4, both pairs of opposite angles are congruent. And in number 5, the diagonals bisect each other. Number 6 is a much trickier problem. What I'm hoping that you see here is that your opposite sides are both parallel. This is parallel to this because if this is my transversal, alternate interior angles are congruent. And these alternate interior angles are also congruent, so these sides are parallel. But we don't have anything that tells us about parallel lines. So what we have to look at in this case now is, do I have one angle, in this case my 58-degree angle, supplementary to its consecutive angles? 82 and 40 is 122 degrees. That's this big angle. 82 and 40 means this big angle is 122 degrees. Since 122 plus 58 equals 180 degrees, this is also a yes, because this angle is supplementary to its consecutive angles. The last type of problem that we're going to look at today is to determine if this quadrilateral with these ordered pairs is a parallelogram. We actually need to do this using not just the slopes, but also we need to do this using the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 quantity squared. Press pause, take a minute, and plot all 4 points, please. Okay, so now we have our points plotted. If we connect it, we have drawn our quadrilateral. The nice thing is, if we're only trying to show parallelogram, we actually don't necessarily need the distance formula. We'll need it in the next few days as we start looking at some of our other special types of quadrilaterals. But for this particular problem, if we can show that opposite sides are parallel, that's the definition of a parallelogram. The slope of BD and the slope of AC should obviously be parallel, Because as I look at them, they're horizontal, and the slope of any horizontal line is 0. So I know that the slope of those two segments are equal. I can use the slope formula to find the slope of AB. A is 0, 0, and B is at 3, 4. Remember, your slope is your change in y over your change in x. You can find your change by looking at your jumps. You jump from 0 to 4, you're going up 4. You jump from 0 to 3, you're going up 3. This is your change in y, 4. This is your change in x, over 3. So this slope is 4 over 3. If you check the slope of your other segment, segment DC, C is at 7, 0, D is at 10, 4, and check your jumps. 0 to 4 is up 4, 7 to 10 is up 3, so your slope is 4/3 again. By definition of a parallelogram, we've just shown opposite sides are parallel. So yes, quadrilateral ABCD would be a parallelogram. There's more to come with problems like this as we try to break this down and determine if it's a more specific type of parallelogram. For now, we want to focus on being able to use the slope formula in these problems. It's always helpful to draw your parallelogram or to draw your quadrilateral first.